Hello and welcome everyone. I am Aryan Choudhary and you are watching Let's Crack JEE. Okay, let me know in the comments whether I'm properly audible and visible. So this is again a lesson on general organic chemistry where we will try to solve a bunch of questions on general organic chemistry. Okay, we will focus mainly on isomerism and we will also solve a bunch of questions on different other topics. Okay, so this is very important, guys. I have always told every one of you that your general organic chemistry is very important, and the reason is it is the everything that you learn in this chapter will be used in all the other chapters that you are going to study in your class 12 standard. So if you are not good at general organic chemistry, it would be very difficult for you to do good in your 12th standard, right? So again, this is a lesson on general organic chemistry. So we will start in a minute or two. Let me know in the chat box whether I'm properly audible and visible. Okay, so those of you who are watching this video for the first time, I am Aryan Choudhary. I'm a graduate of IIT Dhanbad. I cleared my JEE in the year 2016. Okay, so I have launched a couple of courses on this platform. Okay, so I have launched a couple of courses on this platform. So feel free to check those out. At the same time, in my special classes, that is at 2:30 p.m. Okay, so in these classes what we have did is we have covered your reaction mechanism, as well as I have taken a course in which we have covered GOC to your amines. So in all of these courses we have solved more than 30 to 40 questions which will be very useful for you in your JEE mains as well as in your JEE advanced. Okay, moving forward, let's begin our today's session. And before we begin, as you know, right now we are studying on YouTube. It's a completely free platform where we are not able to properly interact with each other, right? So if you want a platform where you want to interact with your teacher, you want to ask doubts to your teacher, right? So in that case you should definitely take the plus subscription. I will tell you about the things that you will get from the subscription. ठीक है, the first thing is डेली लाइफ क्लासेस. सो ना आपके रेगुलर बेसिस पे फिजिक्स केमिस्ट्री मैथ्स के क्लासेस हो रहे रहेंगे. सो इफ यू एनरोल इन एनी ऑफ द कोर्स, व्हाट इज हैपनिंग इन दैट, द थिंग इज कि वहाँ पे क्या होंगे कि आपके रेगुलर बेसिस पे क्लासेस हो रहे रहेंगे. अ पर्टिकुलर टीचर विल बी टीचिंग एट अ पर्टिकुलर टाइम, है ना. तो आपका सारा चीज़ें विल बी कवर्ड इन अ प्रॉपर वे, इन अ प्रॉपर मैनर. एवरीथिंग विल बी स्ट्रक्चर्ड very very finely, and it will be done, everything will be done by ourselves, है ना. So in all of these sessions you can interact with your teacher, you can ask doubts to your teacher. if you देखो जेई का ना, देखो मैंने खुद ने जेई दिया था in 2016. I cleared JEE in the year 2016. तो I know that the structure is very huge. बहुत सारा सिलेबस रहता है. तो it's very important to understand कि कैसे पढ़ना चाहिए. Like everyone, like more than 15 lakh people are giving JEE, right? And you need to be in 1%, right? So yeah, it's the way you study that is very important. So with structured courses ना, we provide you with a way कि आपको कब कौन सी चीज़ें पढ़नी चाहिए. Like yeah, even मैं भी थोड़ा कंफ्यूज होता था जब अपन 11th 12th में थे ना. तो उस टाइम द सिलेबस इज सो ह्यूज, कभी कभी मैं सुबह उठता था और मैं कंफ्यूज होता था कि ओके आज क्या पढ़ना चाहिए. सो दैट वुड नॉट हैपन विथ यू. सो गाइज, टेक द प्लस सब्सक्रिप्शन. And this is the best thing about the plus course, that is your live test and quizzes. Okay, so I believe that it's very important to solve questions on a regular basis, because finally अपने को पेपर में क्वेश्चन ही सॉल्व करने ना, राइट. nobody is going to ask you a theory question, right? So it's very important to solve these questions, get into an habit of solving these questions. So with this live test and quizzes, आपके मंथली बेसिस पे एंड वीकली बेसिस पे यू विल हैव अ लॉट ऑफ डिफरेंट एग्जामिनेशन, जिसके बेसिस पे यू कैन इवेल्युएट वेदर you have a good knowledge on a particular topic or not. Okay, and apart from that there will be more than 100 tests in 2 year of span, where you'll be giving a 3 hours examination just like your JEE. So when you will go to give your JEE examination, you'll be very confident while giving that examination. Okay, and again, as I have told you कि once you will give this examination, so what will happen is आपको पता चलेगा कि okay मेरा ये वाला part weak है. So the next thing that you will do is you will revise those things. So you can revise those things from Unacademy learning app. There are more than 100 courses that are going on the Unacademy learning app right now in the IIT JEE sector. So if you want to revise a particular concept, there will be different teachers will be teaching that, right? Or you can also watch the same video of the teacher that you are following, right? Because it's there, right? आप कभी भी वापस जाके चेकआउट कर सकते हो. चलो, I have told you about the things that you will get from the subscription. Now let's try to understand how to take this subscription. Okay, the first step is download the Unacademy learning app from the Play Store. Okay, second step is you will have a lot of different option on the screen once you download the Unacademy learning app. Okay, so these plans, you can choose a particular plan for yourself, right? This is a very important step. This is very important, guys, to choosing a plan for yourself. Okay, तो जनरली ना मैं आपको 1 year या 2 year का प्लान recommend करता हूँ. The thing is, since the syllabus is very huge, you need at least a year to properly prepare for this examination, right? So the cost of this thing is 38,500, but if you use my code, which is AC01, this is providing you with a 10% discount. So the cost will be 34,650. And for the 2-year subscription, the cost is 56,000. It will reduce to 50,400. Okay, so again you are getting this 10% discount. So choose a plan wisely depending upon if you are in your 11th standard. If you are in your 11th standard, take a 2-year plan, right? But if you are in a 12th standard, right, अगर आप अपने 12th में हो, so you should take this 1-year subscription, right? And there are people who are preparing for JEE even when they are in their 9th or 10th standard. So people, even in that case, you should take 2-year subscription. The cost will be 50,400. So if you will take the course right now, तो आपको क्या होगा? आपका बहुत सारा, you are saving a lot of money, right? So in the Plus subscription, you get a lot of guidance from us, right? So how to follow your dreams and how to study in a proper way. Next thing is, these courses are for the people who are looking for a crash course. Chali. So I hope this is clear to everyone. We will start our today's topic, that is general organic chemistry. We'll be solving a bunch of questions on this topic. So if you want to ask anything, let me know in the comment section. ठीक है? Whenever I'm looking in this direction, I'm looking towards your chat box. So if you want to ask anything, let me know in the comments. Chali, this was the homework from yesterday's class. Okay, so this was the homework. Now let's try to understand कि ऐसे questions try कैसे करने हैं. Whenever you will get a question like this in the examination, what you need to understand? You need to understand, the first thing is that this wedge, this represents a bond which is coming out of the plane, while your dash represents the bond which are on the back side. Okay, so if this is clear, the first step is clear. Okay, next step is always convert these structures into proper sawhorse projection. So I have already taken 5 to 6 lecture on isomerism, where I have explained how to convert your structures into sawhorse projection and then into your Fisher projection. As you can see in the options, all the structures are in their Fisher projection. So what we will do is, today we will learn in this question that how to convert your structure into the Fisher projection. So the first step is to convert it into sawhorse projection, right? So what we will do is, देखो, this is the carbon-carbon bond, so I will draw that bond here, right? So what we have is, we have a CHO group which is pointing in the upward direction. Here we have CHO group which is pointing in the upward direction, right? This OH is coming out of the plane. This is on the wedge, right? So अपने को समझ में आया that this is coming out of the plane. So this is here, right? This hydrogen is on the dash, so it means that it is behind the plane. I hope this is clear. On this carbon, now let's talk about the carbon which is present on the back side. So the carbon which is present on the back side have a hydrogen which is coming out of the plane, and OH group which is going behind the plane, right? तो यहाँ पे अपन ना, like instead of doing this thing, अपन इसको normally भी लिख सकते हैं, ठीक है? And you have CH2OH. This is our CH2OH, right? So this CH2OH is pointing downwards. Okay, so we have this structure. Now what we will do is, we will try to understand that how to convert this structure into Fisher projection. The first thing that you need to do in all of these structures, क्या करने का होता है? The first step is, देखो, what we do is, अपन ना, we put 2 of the bonds pointing in the vertical top direction. So in this carbon we have a CHO group which is pointing in the upward direction. Okay, now what I will do is, मैंने options देखा and मुझे options में दिख रहा है that CHO and CH2OH are present on the vertical lines. So now what I will do is I will rotate compound by 180 degree so that this CH2OH will come on the top side, the Sawhorse projection into the Fisher projection. So to convert these structures into Fisher projection, अपन क्या करते हैं, we lie down on the floor, we lie down here, ठीक है, assume that you are lying on the floor and you are watching this compound from here. So when you will be watching this compound from the bottom, you will see that these bonds are coming towards you, these are facing toward your face. So these will be like this OH will be here, the hydrogen will be on this side, the CHO group is on the backward, right? So the CHO will be present here. On the second carbon, on this carbon, you will again see that you have a OH group here, a hydrogen here, and CH2OH group here, right? So as you know, on the Fisher projection, these bonds are coming out of the plane, right? While the bonds which are present on the vertical, these are going backwards. I hope this is clear to everyone. So the correct answer of this question is B. Okay, so the first step was to convert the structure into Sawhorse projection, and secondly what we did is we convert the Sawhorse projection into Fisher projection. So I am always looking toward the chat box. The chat box is in this direction, so if you have any doubt, let me know. So we have completed that question. So in this question, what you have been asked is the correct decreasing order of priority for the functional group of organic compound in the IUPAC system में ना, these are the groups, ठीक है, these are the functional groups which are attached to your carbons, right? So you just need to find the correct order of priority. I hope this is a very easy question, so I hope सबको पता होगा what is the order. So this is given in your NCERT too. So this question was asked in your EEE 2008, right? So उस time पे there were a lot of questions which were very very easy. So this is very easy, guys. The correct answer of this question is A option. Okay, so in the A option, what you have is you have carboxylic acid, sulfonic acid, then your amide and your CHO. So your acids have more priority when you are selecting the main functional group in any of the organic compound, then your SO3H, then comes your acid derivatives. We know that amide is an acid derivative, right? So after amide you have ester, right? And then comes your aldehyde के बाद आते हैं your ketones. So I hope everyone have seen the order. ये question तो बहुत easy था. Let's try to do this question. Okay, so in this question, what you need to do is you need to arrange the following compounds in decreasing order of stability. So you have a carbanion in all of these structures, right? So you have carbanion in all of these structures. You need to check out of these carbanion which one is more stable, what is the order. Okay guys, I am giving you 1 minute to solve this question. Okay, you have 1 minute. I will looking toward the chat box. What I will do is I have to fill my bottle, so I will come back in a minute. So I hope सब लोगों ने ये क्वेश्चन ट्राई कर लिया होगा. Now let's try to understand ki how to solve these type of questions. So the thing is, whenever you have any questions on the stability of carbocation or carboanion, so what you need to do is, देखो आपके पास ना जो ग्रुप्स है ना, write the effects of these groups, right? So you have a OCS3 group, we know that is the plus M group, and a minus I group. Okay, this here, since it is present on the meta position, this is only providing us with a minus I effect. This will not have any mesomeric effect. Okay, and in this case this is present on the para, so it will have plus M and a slight minus I, right? We know that your minus I effect is dependent on distance. So as you move away from this position, the minus I effect will reduce, right? So now the thing is, देखो, we know that we have a carbon ion, so we know that to stabilize a negative charge we need to take those electrons from this negative charge, है ना? But we know that since OCS3 is a plus M group, it is donating its lone pair to the system, so it is destabilizing our carbon ion. So your second structure will be more stable one. Okay, this is more stable structure. Okay, I hope this is clear, because in this case you don't have any mesomeric effect. Now between first and third, this is important, between first and third में क्या हो रहा है? First and third में you have mesomeric effect, and mesomeric effect does not depend on the distance. So mesomeric effect के basis पे अपन जज नहीं कर सकते, we will judge on the basis of inductive effect. Since minus I effects वाले जो ग्रुप होते हैं ना, those pull those electrons, these groups pull the electron from the system. So since on in this case you have OCS3 group on the ortho position, this will have more inductive effect compared to the para one. So the order is second, first, and last will be third. So the correct answer is C. I hope this is clear to everyone. चलिए, moving forward, in this question what you need to do is you need to find the configuration, you need to find the RS configuration. First thing is, देखो, you need to, whenever you have these type of questions, the first thing is do the numbering, है ना? Numbering करना important है. You need to understand, देखो, these two carbons are chiral, right? So you need to understand this is the second carbon, this is the third carbon. The numbering will be done from this carbon, right? So you have a COH group here. I hope this is clear to everyone. This question was asked in 2016 JEE Mains. This is the year when I gave my JEE Mains. Okay. So I have already explained a lot of time how to find your RS configuration. So in this question, the first thing is assign the priority to the groups which are directly bonded to these chiral carbon. So the first thing is, देखो, this is the C2 carbon, this is the C3 carbon, right? Now you just need to find the RS configuration. The first step is assign priority. So if you are watching this video, let me know in the comment section. मैं comments के section में मैं live chat हमेशा देखता रहता हूँ, ठीक है? I am waiting for you to answer this question in the comments. चलो, first step is assign priority. This is the first priority group, right? This is first priority. Okay, this carbon will have the second priority. This COH is having the third priority, and hydrogen will have the fourth priority. I hope this is clear to everyone. देखो, अगर मैं ये कार्बन यहाँ पे ड्रॉ करूँ ना, you have a OH group. On this carbon you have देखो, जब priority is given by your CIP rules. So CIP rules के according क्या होता है? If you have a double bond, that is taken as single bonds, right? On this carbon, here you have a carbon which has a carbon-chlorine bond. That is why this carbon will have higher priority. So this is how we will give the priority. Once we have given the priority, what we do is we move from 1 to 2 and 2 to 3. Okay, so we moved from 1 to 2 and 2 to 3. This is clockwise, but your fourth priority group is present on the horizontal. तो जो भी आपका कॉन्फ़िगरेशन आता है ना, अपन क्या करते हैं, उसका अपोजिट लेते हैं, राइट? सो दिस कार्बन has a configuration which is S, right? Now on this carbon, let's talk about this carbon. In this case, this will have the first priority. This bond which is going up, that will have the second priority. This CH3 is having the third priority, and hydrogen is having the fourth priority. Again, your fourth priority group is present on the horizontal. So we will move from 1 to 2 and 2 to 3. But again, your fourth priority is on the this place. So what we do is अपन reverse कर देते हैं. So this is R. So the first carbon is S and second is R. So the correct answer is A. I hope this is clear to everyone. We will move forward. This is a very important question that has been asked in the year 2012. Okay. This is a multi-carat question. So what you have in this question is, you have been provided with M, N, O, P, Q. Okay. So आपको पूछा है, these are the options. So which of the given statements about N, O, P, okay, यहाँ पे M miss हो गया. So M, N, O, P, Q with, okay, M है, right? So which of these statements are right? You need to tell, right? So whenever you have these type of questions, what you need to do is, first thing is, try to convert these structures into Fisher projection. Either you can do via Fisher projection, convert these structures into Fisher projection, or the second way is, मैं आपको आज एक different way बताऊंगा, that is through visualization. तो अगर आप, if you can visualize these things, ठीक है, चलो, what we will do is, on this page we have these structures. We will try to देखो ऐसे क्वेश्चंस के लिए ना आप ऑप्शन वाइज जाओ. फर्स्ट थिंग इज, इन द फर्स्ट ऑप्शन यू हैव बीन सेड दैट M and N आर नॉन मिरर इमेज स्टीरियो आइसोमर्स, राइट? सो अपने को फर्स्टली चेक करना है वेदर दीज टू आर मिरर इमेज ऑफ ईच अदर और नॉट. ठीक है, चलो, फर्स्ट थिंग इज, देखो, ऑन दिस कार्बन यू हैव OH, क्लोरीन एंड हाइड्रोजन, राइट? ओके, ठीक है. तो अपन क्या करते हैं, अपने पास N है, ठीक है. N में क्या है, देखो, फर्स्टली आपके इस M में ना क्लोरीन इज बॉन्डेड टू द पीछे वाला कार्बन, वाइल इन द N में क्या हो रहा है, द क्लोरीन इज बॉन्डेड टू द फ्रंट कार्बन. तो अपन क्या करेंगे, फर्स्ट थिंग दैट वी विल डू इज, वी विल रोटेट दिस कंपाउंड बाय 180 डिग्री. सो व्हेन वी विल रोटेट दिस कंपाउंड बाय 180 डिग्री, वी विल गेट अ कंपाउंड that will look something like this. Your OH will be here, your hydrogen is here, your chlorine is here, your CH3 is pointing in the downward direction. Since you have rotated, your hydrogen will be here and your OH is here. So you can see these two compounds are not mirror image of each other, right? जो पीछे वाला कार्बन है उस पे the way these structures are arranged is same, right? While on the first carbon what you have is, first carbon यहाँ पे आपका OH was on the left side, while in this structure you have OH on the right side. So these two are stereoisomers of each other. They are not mirror image of each other, but they are isomers, right? So first option क्या था अपने पास, M and N are non mirror image stereoisomers. So this is correct. So these two are not mirror image of each other and they are also stereoisomers. चलिए, next thing is for O. So the second option is M and O are identical. तो आपको बोला है कि that M and N are identical. Okay. So identical होने के लिए the first thing is you can also do via your RS configuration. So to find the RS configuration, what you need to do is you need to convert these structures into Fisher projection, and after that you can find the RS configuration, right? But that is a lengthy way to do these questions. You will not have that much time in the examination to do this question in that way. So यहाँ पे क्या करते हैं अपन, देखो, आप यहाँ पे assume करो, देखो, this is the first carbon, the orientation of the groups are same for M and O, right? तो यहाँ पे आप देखोगे on the first carbon पे दोनों चीज़ें सेम है, while in the second carbon what we will do is we will rotate this by 180 degree. So when we will rotate this compound by 180 degree, your compound will look something like this. Your hydrogen will be on this side, you will have OH here, chlorine will be on the downward direction, CH3 is in the downward direction, you have hydrogen and OH is here. So now you can see that M and O are having the same structures, right? So your second statement is also correct, that M and O are identical. Okay, next thing is M and P are enantiomers. So what we will do is, this is OP and Q are drawn in the Newman projection. So the first thing that we will do is we'll convert them into Sawhorse projection. So if I will draw the Sawhorse projection of this compound, okay, you have chlorine pointing in the downward direction, CH3 pointing in the upward direction on the back carbon. Okay, that was on the back carbon. Just wait for a minute, guys. Okay, I will draw it for you. This is my first carbon, and the जो पीछे है that is my second carbon. So on the first carbon we have CH3 at the top, OH on this side and hydrogen on this side. At the back carbon we have chlorine pointing in the downward direction, OH here and hydrogen here, right? Now what we will do is, we will rotate this. If I will rotate the carbon, which is this is my first carbon, so okay, this is my C1. So I will rotate this fan by 180 degree. ठीक है, since I am rotating it, पीछे वाला कार्बन तो सेम रहेगा. On the first carbon, the CH3 will be pointing inward in the downward direction. So I hope this is visible, right? You will have OH here and a hydrogen here. Okay, now you can see देखो that M and O, if you place a mirror here, you will get this compound P. So अपने को समझ में आया that C statement is also correct, that M and P are enantiomers, right? तो यहाँ पे नीचे you have CH3. Okay, I hope this is clear to everyone. Last is M and Q are identical. तो अपन ना क्या करते हैं, Q को भी we'll draw the Q structure here. We'll draw the Sawhorse projection. So this is my first carbon. So on the first carbon we have CH3 pointing upwards, OH on this side and hydrogen here, and on the back side we have chlorine pointing in the downward direction, OH here and hydrogen here. So देखो previous जो पीछे वाला कार्बन है ना, उस पे the arrangement is same, right? So what I will do is I will rotate the first carbon by 180 degree so that your CH3 is pointing in the downward direction. So your CH3 is pointing in the downward direction. Your OH will come on this side, the hydrogen will be on this side. यहाँ पे you have hydrogen here and OH here and chlorine here. तो यहाँ पे आप देख सकते हो that M and Q are not identical. The reason is, पीछे वाले कार्बन पे तो orientation same है, but on the first carbon the orientation is completely different, right? So the correct answer of that question is A, B and C. I hope this is clear to everyone. ठीक है, ये बहुत अच्छा क्वेश्चन था. तो द थिंग इज, देखो एग्जामिनेशन में व्हाट यू नीड टू डू इज, मैंने तो यहाँ पे ड्रॉ किया ना, आपको ड्रॉ भी नहीं करना था. आप ना इफ़ यू कैन जस्ट विजुअलाइज दीज क्वेश्चन इन योर माइंड. अगर देखो बिटवीन जैसे एम एंड एन का जो थिंग है, आप सिंपली ना, आपको दिख रहा है कि फर्स्ट आप क्या करो, उसको ऐसे पकड़ो और आप इफ़ यू कुड फ्लिप दैट, और अगर आप वो इमेजिन कर पा रहे हो, देन यू कैन इजीली डू दीज क्वेश्चन इन द एग्जामिनेशन, राइट? सिमिलरली देखो पी एंड क्यू के लिए आपको तो फटाफट यू नीडेड टू ड्रॉ दीज सॉहर्स प्रोजेक्शन, तो ये करना बहुत इंपॉर्टेंट था. या रूपल इज आस्किंग अस स्ट्रैटेजी फॉर जेई, हाउ टू गेट गुड रैंक इन जेई. या रूपल, वी विल डिस्कस दैट एट द एंड ऑफ द लेक्चर. आप एंड तक वेट ही नहीं करते हो. सो राइट नाउ वी आर डूइंग दीज क्वेश्चंस. देखो स्ट्रैटेजी बहुत सिंपल है. द फर्स्ट थिंग इज कि आपका सही से रिवीजन होना चाहिए. सेकेंड थिंग इज यू नीड टू सॉल्व दीज क्वेश्चंस. अगर आप रेगुलर बेसिस पे क्वेश्चन सॉल्व नहीं करोगे तो यू विल नेवर बी एबल टू डू इट प्रॉपरली इन योर एग्जामिनेशन. सो मैं बिलीव करता हूँ दैट यू नीड टू सॉल्व क्वेश्चंस ऑन अ रेगुलर बेसिस. बहुत सारे क्वेश्चन सॉल्व करो, स्टार्ट सॉल्विंग क्वेश्चन फ्रॉम एवरीवेयर. चीज़ें फिक्सेट कर लो. रोज मत सोचो कि आज मैं यहाँ से सॉल्व करूँ या यहाँ से करूँ. एक बार पहले फिक्सेट कर लो चीज़ें. स्टार्ट सॉल्विंग क्वेश्चन फ्रॉम योर प्रीवियस ईयर्स. स्टार्ट सॉल्विंग क्वेश्चन फ्रॉम योर नेशनल अभ्यास टेस्ट. ओके, डिटेल में चाहिए तो आई विल बी मेकिंग अ वीडियो ऑन दैट. मैं बहुत रिसेंटली आई विल मेक अ वीडियो लाइक हाउ टू प्रॉपरली स्टडी फ्रॉम विच प्लेस यू शुड स्टडी एंड व्हाट आर द बुक्स यू शुड रेफर. देखो, आई क्लियर्ड माई जेई इन द ईयर 2016. मेरा जेई मेंस में मार्क्स था 184. एट दैट टाइम जेई में जेई होता था 360 का. ओके, आई डोंट रिमेंबर द रैंक इन माई जेई मेंस. एंड इन जेई एडवांस माई रैंक वॉज 8832. आई एम अ ग्रेजुएट फ्रॉम IIT धनबाद. ओके, जेई मेंस का मेरे को रैंक याद नहीं है, बट द मार्क्स वॉज 184 एंड दिस वॉज द रैंक ऑफ जेई एडवांस. चलिए, मूविंग फॉरवर्ड, this question which has been asked in the year 2019 is very important. Okay, this is very important. देखो, जनरली ना हर साल मैंने देखा है कि एक क्वेश्चन तो पक्का आ जाता है अमाइंस में, जहाँ पे ना यू नीड टू यूज द कॉन्सेप्ट ऑफ एनिलीन, पायरॉल एंड pyridine. So this is your aniline. Okay, this is your, okay, just wait for a minute. This is your pyridine and this is your pyrrole. Okay, so in this question what have been asked to you have been asked like out of A, B, C, D, E, what are the centers which of these nitrogen will act as a base. आपको बेसिकली पूछा है कि फेवरेबल साइट ऑफ प्रोटोनेशन. सो बेसिकली आपको बेसिसिटी पूछ रहे हैं ऑफ दीज नाइट्रोजन, राइट. वी नो दैट दीज नाइट्रोजन हैज लोन पेयर टू देम. ओके, तो आपको बस चेक करना है वेदर these lone pairs are available for the nitrogen to donate or these lone pairs are busy. देखो, we have seen in the case of aniline then these lone pair of nitrogen are participating in the resonance with the benzene ring. So these lone pairs are not always available. So आपका जो aniline है ना, this does not always act as a base, right, because these electron of these nitrogen are participating in resonance with the benzene ring. Next thing is the case of your pyridine. So in the case of pyridine, what happens is these lone pairs of nitrogen is not participating in the resonance. Okay, the thing is, देखो, this nitrogen is a sp2 nitrogen, right. So this lone pair is in the same plane with the benzene ring, right. So these lone pair of nitrogen are not able to participate in the resonance, right. So these lone pairs are always available to this nitrogen. So this nitrogen of pyridine can act as a base. Okay, now how to identify whether a structure is like pyridine. So in your examination you just need to identify whether the structure is looking like your pyridine, pyrrole or aniline. While in the case of pyrrole, what is happening, these lone pairs of this nitrogen is participating in the aromaticity. So since this lone pair of this nitrogen is participating in the aromaticity, these lone pairs are not available. Since these lone pairs are not available, right, because these are participating in the resonance, every structure try to attain stability, right, and aromaticity provides a lot of stability to our compounds. So since these lone pairs are not available, this will not act as a base. Okay, so between your aniline, pyridine and pyrrole, only pyridine can act as a base. Now in this structure, you just need to find out whether these structures are like your aniline, pyridine or pyrrole. So देखो, this nitrogen is like your aniline, so this will not act as a base. This nitrogen, the B nitrogen is like your pyridine. देखो, pyridine में क्या होता है? You have a double bond just next to this nitrogen, right? So this nitrogen is a sp2 nitrogen. ठीक है, ये देखो यहाँ पे यू हैड sp3 एंड यहाँ पे भी दिस नाइट्रोजन वाज sp3. So this nitrogen, which is a sp2 nitrogen, is like pyridine, so this will act as a base, right? This C nitrogen is also like your pyridine, so this will also act as a base. If I will talk about the D nitrogen, this is again like your pyridine, right? So you have a double bond next to this nitrogen, this is again sp2, so this is like your pyridine, so it will act as a base. While the last nitrogen, that is your E nitrogen, this is like your pyrrole, right? है ना, ये sp3 है. This can donate these lone pair into the system, so this will not act as a base. So your B, C and D nitrogen are like your pyridine, so that will only act as a base. So the correct answer of this question is B option. I hope this is clear to everyone. We will move forward to the next question. So this question has been asked in the year 2017. So you just need to find out which of the following molecule is least resonance stabilized. Okay. This is a very easy question, guys. So एक बार आराम से try करो. If you are watching this video, you can comment in the comment box. I am always looking toward the comment box. देखो, the first structure is the case of benzene. So in the case of benzene, we know that the resonance is making this benzene more stable. It is giving more stability to the benzene, right? And we have seen the case of pyrrole. This pyrrole is aromatic, right? It is aromatic because this is like your pyrrole. This is furan, right? This is furan, where instead of nitrogen you have oxygen. So here these lone pair of oxygen are participating in the resonance. So this is aromatic, right? You have cyclic resonance in this structure. Okay, so in both A and B are getting more stability from resonance, right? So A or B the options नहीं होंगे. This is again your pyridine. We have seen this is again aromatic. यहाँ पे you have cyclic resonance, right? So this is again your resonance is providing stability to your pyridine. In this question, what you have is, देखो यहाँ पे you have a sp3 carbon. This is not planar, right? You don't have cyclic resonance. No cyclic resonance, right? So आपको पूछा था least resonance stabilized structure find out करना था. So the D structure is the least resonance stabilized structure. Next question. In this question, what you need to do is you need to find the increasing order of nucleophilicity of the following nucleophile. So this question was asked in your JEE 2019. This is a very recent question. So you just need to find out of 1, 2, 3, 4, what is the order of nucleophilicity. So again, this is again a very easy question, guys. एग्जाम में आप बहुत जल्दी कर सकते हो ये क्वेश्चन. तो द फर्स्ट थिंग इज, देखो, ऑन फर्स्ट, थर्ड एंड फोर्थ what you have is you have a negative charge. We know that if you have a negative charge, that will act as a better nucleophile, है ना? Since this is water, this does not have a negative charge on it. The oxygen does not have a negative charge on it, so this will not act as a good nucleophile, right? Out of 1, 2, 3, 4, this will be the least. Okay, this will have the least nucleophilicity. So अपने को समझ में आ गया that water will have the least nucleophilicity. Now between first, third and fourth, you need this negative charge to donate, right? So ये negative charge stabilize नहीं होने चाहिए. So the thing is, between यहाँ पे क्या हो रहा है? You have this structure. This negative charge is in resonance, right? Similarly, this negative charge is again in resonance. Here what you have is, you have this thing. So in both of these cases, what you have is the negative charge is in resonance. So आपका this will have the maximum nucleophilicity. So आप अगर आप बस ये फाइंड आउट कर लेते तो आपको आंसर समझ में आ जाता. The answer is this thing. Your fourth will have the maximum nucleophilicity. Second will have the least. Between between third and first will have more nucleophilicity character. So the order is fourth will have the maximum nucleophilicity, then your first, then your third, and last will be second. So this is the correct order. So the correct answer is B option. Okay. Moving forward, let's try this question. This question was asked in the year 2016 advance. So this is the year when I gave my JEE advance. So this was a question that I done in my examination. Okay. So you need to find the correct order of acidity of the following compounds, right? So if you have studied the concept of ortho effect, तो आप बहुत easily ये question कर सकते हो. If we have a OH group present on the ortho, what happens is it increases the acidity of your carboxylic acid. ठीक है, that is the hint. एक बार खुद से try करो. I will solve this question for you in a minute. Okay, sure. Let me solve these questions for you. In this question, what you have is, देखो ortho effect में क्या होता है, that if you have a group which is present on the ortho of a carboxylic acid, that is, if you have any group that is present on the ortho position, this increases the acidity of your acid. Okay. So in this case, in the first option, what you have is you have two OH groups on the ortho, right? So the first structure will have the most acidity. ठीक है. Again, since the first will have the most acidity, third will have the second, because again you have a group which is present on the ortho. ठीक है. तो अगर आपने इतना ही फिगर आउट किया तो आपको समझ गया था करेक्ट आंसर इज डी. सिंपल. Chalo, moving forward, in this question what you need to do is you need to find the correct acidity order of the following compound. The correct acidity order of the following compound. So you have four different groups. देखो first thing is we know that acids are more acidic than your phenol, and between third and fourth we know that third is more acidic than your fourth, and between first and second we know that second is more acidic. So simply the order will be third, then your fourth, then second, and first. So this is the A option. So these are very easy questions that has been asked over and over on different topics of general organic chemistry in your JEE Mains as well as advanced. So it's very important to solve these questions so you will get into a habit of understanding कि कैसे concept पे कैसे questions बनते हैं. Okay. So try to solve this question. In this question, you need to find out among the following the total number of compounds soluble in NaOH. So you need to find the number of compounds which are soluble in NaOH. Right, we know that your acids, phenols, right, these groups react with NaOH, है ना? So if you have any hydrogen bonded to these oxygens or nitrogen, right, in all of these cases these will react with NaOH, right? तो आपका एक साइड तो water बनता है, and the second hand, instead of that hydrogen that is attached to these oxygens and nitrogen, आपका sodium will replace that hydrogen. So एक बार खुद से try करो, I will explain in a minute. Chalo. So in the first structure, you don't have any hydrogen attached to these nitrogen, so this will not react with NaOH. While the second structure has a carboxylic acid, this hydrogen can be replaced by NaOH and you will get sodium salt of carboxylic acid. So this is the first structure that will react with NaOH. This will not react with NaOH, right? We have a OH group, that is a phenol, right? So this hydrogen can be replaced by a sodium. So this is the second structure that will react with your NaOH. In this case, this structure, ये बताओ फटाफट मुझे बताओ whether this will react with NaOH or not. Yeah, this will not react with NaOH. You don't have phenols, you have a normal 1 degree alcohol. So your alcohol does not react with NaOH. Okay, so this will not react with NaOH, this will react with NaOH, and this will react with NaOH. So you have 4 structures which are reacting with NaOH. I hope this is clear to everyone. This is the next question. So in this question, you need to find the total number of contributing structures. You need to find the total number of contributing structures showing hyperconjugation. Simply, you need to find the number of alpha hydrogens available, which can, we know that, dekho, your hyperconjugation provides stability to your carbocation. So in this question, you just need to find the number of alpha hydrogen that is available to stabilize this carbocation. Chalo. So this is the carbocation. It is bonded to, here you have 3 alpha hydrogen, here you have 2 alpha hydrogen. Okay. Now the thing is, एक और अल्फा हाइड्रोजन है जो सब लोग मिस कर देते हैं. द थिंग इज, देखो यहाँ पे जो कार्बन है ना, it has 3 bonds. The 4th bond is your hydrogen, right? So you have 3 to 5 1 6. The correct answer is 6. You have 6 number of alpha hydrogen in this case. I hope this is clear. So we are almost near our this video is almost about to end. So अपन ना क्या करते हैं, the last 3 to 4 minutes is a doubt session. So if you want to ask anything, I am always looking toward the chat box. Let me know in the chat box. This is the last question of our today's session. So I will explain this question to you. एक बार खुद से try करो. After that, we'll have a 5-minute doubt session. If you want to ask anything, let me know in the comment section in the live chat. Whenever I'm looking in this direction, I'm looking towards the chat box. I'm waiting for you to try this question out. Okay, so let me know in the chat box. I will wait 30 more seconds for you to try this question. Dekho, you have been asked the correct stability order of the following resonating structure. So there is a way to find out whether, like, which resonating structure is more stable. So the first thing is, I will tell you the rules. The first thing is, the structure which will have more bonds will have more stability. More bonds / complete octet. Second thing is, if देखो, this is the order in which how you need to check whether which one is more stable. If you have same number of bonds, then you should check for less number of charges. Okay, so if you have less number of charges in the resonating structure, that resonating structure will be more stable resonating structure. If you have same number of charges, then you need to know that कि आपके जो opposite charges है ना, your opposite charges should be close. Okay, and even if this is also same, then you need to understand कि आपका जो negative charge है ना, negative charge should be on more electronegative atom. So this is how you check where, like, which resonating structure is the more stable resonating structure. So I'm waiting for you to comment in the comment section. Chalo, let me explain this for you. The first thing is we need more number of bonds. So in this we have 4 bonds. Like, I will be only counting these bonds. So we have 4 bonds. Here we have 3 bonds. Here we have 4 bonds. And here we have 3 bonds. So अपने को समझ में आ गया that third and first will are more stable resonating structures, है ना, because you have 4 bonds. Okay, while your second and fourth is having only 3 bonds, right? Now between first and third, let's try to understand. देखो first and third में क्या हो रहा है? Between first and third, your first will be more stable than your third. The reason is, देखो, here the negative charge is on nitrogen, while in this case the negative charge is on this carbon, right? We have seen कि आपका जो negative charge है ना, that should be present on more electronegative atom, right? So अपने को समझ में आया that first will be more stable than your third. Now between second and fourth you have same number of bonds, you have same number of charges, you have, yeah, आपके opposite charges are separated by the same distance. The last thing is you need to understand कि जो आपका जो negative charge है ना, that should be present on the more electronegative atom, right? So between second and fourth, आपका second will be more stable. The reason is here you have negative charge on nitrogen, while in the case of fourth the negative charge is present on the carbon, right? So this is the order. So the correct answer is B. Okay, so try this question by yourself. This is a homework question, ठीक है? This is a multi-correct question, guys, and this is very important. I will tell you few things about these questions. देखो यहाँ पे what you have is you have NO2 group here, right? So these, what these NO2 groups is doing, देखो यहाँ पे you have a bromine, and next to these bromines you have NO2 groups. So this NO2 group is very huge. It is very huge. Here the bromine is very huge, and again you have a NO2 group which is very huge. So there will be a lot of repulsion between these NO2 groups and your bromine. So once they, so due to that आपका क्या होगा ना, due to this आपका क्या होगा, these NO2 groups will go out of the plane. So यहाँ पे this NO2 groups are not participating in the resonance with the benzene ring, while this NO2 is participating in resonance with the benzene ring. ठीक है, I have explained few things about this question. एक बार खुद से try करना. Okay, and this is again a homework. ठीक है, आराम से क्वेश्चन रीड आउट करो. विच ऑफ द फॉलोइंग कॉम्बिनेशन अमंग द 4 फिशर प्रोजेक्शन रिप्रेजेंट द सेम एब्सोल्यूट कॉन्फिगरेशन? So you just need to find the RS configuration. Simple है, you can do this question by yourself. And this is again a multi-carat question where you need to find out whether each of these structures has a plane of symmetry, axis of symmetry, center of symmetry, or they will rotate the PPL light. Okay. So I will end this lecture in a minute or two. So before I will end this lecture, guys, if you want to take the plus subscription, there are a lot of different options available on the screen, so you can choose a plan for yourself accordingly. Generally I recommend a 1 year and a 2 year plan, है ना? These are the prices. These are the prices for your plus subscription. Okay, recently we have also launched the iconic subscription. So if you, I will let you know about the iconic subscription in a few days, but these are the prices for your plus subscription. Okay, and before I will end this lecture, from 1st October, this is very important, from 1st October I am starting a new course on in organic chemistry. So what we will do in this course is we will cover your S block. Okay. Simultaneously, I will be also taking classes on organic chemistry. We will be doing alkyl halides. So these are the two topics that I will be starting in the month of October. Okay. Bye bye guys.